Hello, and welcome to The Course. I'm your host today, Martha, and I'm speaking with Professor Leslie Rogers from the Department of Astronomy and Astrophysics. Professor Rogers studies the formation, interior structure, and evolution of exoplanets. She has a PhD from MIT and is the recipient of a 2020 Cottrell Scholar Award. She's here to talk with us about her career path and how she became a University of Chicago professor. Welcome to The Course, Professor Rogers.
Hi, I'm Leslie Rogers, and I'm an assistant professor in the Department of Astronomy and Astrophysics here at the University of Chicago.
Well, welcome again. So your field, is not only fascinating, but also, where you've already gotten in this field is pretty impressive. But every superhero has an origin story. So I'd love to go back in time just a little bit to sort of how you became interested in the stars in space as a child. So where does that story start for you?
Yeah, so for me, that story starts in a small fishing town in Nova Scotia, which is where my family is from and where I grew up. And as I was growing up, I had a wide range of interests, though kind of science and physics was among them. And there was very little light pollution where I grew up. And so even though the weather was often foggy or cloudy, on the nights where the weather was fair, I could just see kind of a brilliant array of stars. And so that was kind of the environment in which I grew up, is just having, whenever it wasn't cloudy or foggy, and kind of being kind of bathed in the starlight.
Oh, I mean, that sounds pretty idyllic. And was this beautiful, stargazing just in the place where you were growing up? Was this sort of wonder that you were feeling something, you were sharing with family? Was this something that was very much your own? Would you be out there by yourself looking up at the sky, or was this part of a family interest?
So it was part of a family interest. I mean, I have fond memories of watching meteor showers with my dad and my sisters together at night. But it was also almost kind of a nearly everyday kind of day-to-day occurrence, kind of walking from the car into the house, and on a clear night, being able to see Orion and the Big Dipper, kind of looking at the constellations and just, seeing kind of a far wider range of stars than we see every day in Chicago on a continual basis.
Right. Sort of, you didn't have to try to see it. It was just part of the world you were in.
Yeah, it was part of the world I was in. And of course, there would sometimes be special astronomical events like a meteor shower or a comet or something where we would deliberately or mindfully stargazing or go out to stargaze. But yeah, it's more the, I think, continual day-to-day exposure that started to spark my interest. And now I'm studying the planets that were orbiting all of those stars that I gazed upon as a child.
Yeah. And when did you realize, or how did you realize that the stars were something you could study? When did you learn that this was actually a field of, that people had careers in, or at least that you could study further?
Yeah, I guess that kind of started for me when I was in college. So I went to university at the University of Ottawa, and I did a Bachelor of Science in Physics and Math. But then during the summers, I got an undergrad research position at Mount Allison University to try to be a bit closer to home. It's also in Atlantic Canada. And in that research position, I was studying shooting stars, or I was studying the ablation of meteors in the Earth's atmosphere. And that was both kind of observationally. We would literally go out at night with kind of image intensified video cameras to videograph meteors and count their rates. But then it also involved working on a computer to model kind of the process through which these grains of sand would be kind of heated up and kind of vaporized in the Earth's atmosphere and create the shooting stars that we enjoy on the ground. And so for me, that was my first taste of research and my first real exposure to kind of planetary science or astronomy as an actual profession that people did, that it's not just kind of a hobbyist, but it's actually something that you could pursue as a career.
Right. And, you said you were studying physics and mathematics. Did you have a sort of a pre-existing idea of what you might want to do with that? And this sort of shifted that? Or were you really kind of exploring it all and not quite sure yet?
I was really exploring it all and not quite sure yet. So, I mean, when I was in high school and trying to figure out what to do in college, I was interested in science, but I was also interested in dance and music. Ultimately, I ended up deciding to pursue science, like physics, in college, because I figured it might be a little bit easier to still have music and dance as hobbies and kind of physics as more of a career, as opposed to trying to be a professional musician or dancer. That seemed pretty challenging, but also it seemed rather challenging to have kind of a physics lab in my basement as a hobby.
Right. Yeah, like both
I'm
sides
sure there
of
are ways
that
to do
actually don't work
it.
out.
Yeah, but that was part of my thought process at the time was, okay, I had a wonderful and very inspiring high school physics teacher. I loved my physics class as a high school student. And so I decided to pursue that in college, not with a clear vision of what to do with it afterwards, but just realizing that I would probably learn a lot about the natural world around me, the physical laws governing how planets and stars move, are the natural world, but then also hopefully acquire a bunch of transferable skills that would be applicable to a wide range of future career options, even if I had a very nebulous idea of what those options might be.
Right. You're like, the things I'm doing now will be useful in many ways, even if I don't yet know what they are.
Exactly.
Yeah. So going back to that very inspiring physics teacher, how did she specifically inspire you at that time?
Yeah, well, one way was just as an example of kind of a very independent, intelligent kind of woman scientist. There weren't necessarily that many examples of that I was exposed to in the media kind of growing up in the 90s at the time. So just as a kind of an aspirational figure, she was very inspiring. But also, I really enjoyed her classes because she taught the fundamentals, but also she herself had a deep curiosity to kind of learn more and push a little bit beyond kind of the standard high school curriculum. And she would sprinkle those more advanced concepts or maybe more cutting edge research concepts that she had learned about herself throughout the class. And so that also kind of gave some hints that, okay, we're not just learning, well, I guess in high school we were learning kind of Newton's laws, pretty well established kind of laws, but she kind of hinted at the possibility that there's, within the field of physics, there's this broader unknown, that there is an envelope kind of beyond which there's a lot that we don't understand.
Right.
And I found that very compelling and enticing.
Yeah, beautiful, right? Like this idea that you're not just, memorizing what has been known for ages and ages and that's it, case closed. But that, as you said, there is so much unknown and you could be exploring and even figuring some of those things out.
Right. Yeah.
Okay, so now you're in college and you've had this experience at Mount Allison. Where does the story take us from there?
Yeah. So after having kind of a positive experience working on research as an undergrad student, I found out from kind of my research advisor, Dr. Hawks, as well as kind of more senior undergrad researchers who had kind of gone through this process a year or two ahead of me, that kind of about how to apply to a grad school, and that in graduate school, you don't typically pay tuition, but rather you actually get paid to continue your studies and work on research. And that was a complete eye-opener to me. And so given that, as I said, I kind of had a very nebulous idea of what life after college would look like, and I enjoyed research and enjoyed kind of exploring and figuring out new things, kind of this possibility that my kind of job effectively for the next several years could potentially be kind of learning new things and doing more research. That seems like a dream come true.
Yeah, getting paid to learn. Sign me up.
Yeah. I mean, and grad school is stressful. Like there's definitely times that are stressful. Kind of no one's going to say that candidacy exams were the best moment of their life or something like that. But on the whole, I think it is I feel very grateful to have had the experience to pursue a PhD in physics. And I feel like it was a tremendous learning experience for me, both professionally and learning all the physics and astronomy that I did during that time and how to be an independent researcher, but also a personal learning experience as well. I mean, I had grown up in a small town in Nova Scotia, and so getting to study at MIT was something that I hadn't really imagined in my wildest dreams growing up. And by the time I got there, I kind of encountered kind of intellectual challenges that I really hadn't encountered prior to that. So it was definitely an eye-opening experience for me in many ways.
And did that feel, once you were in that environment that you hadn't necessarily imagined you'd ever be in, and butting up against those challenges, did that feel thrilling? Did that feel intimidating? Some combination of the two?
I think some combination of the two. Yeah, I think it was some combination of the two. And certainly, I mean, the first year or two in grad school, I think that transition to a new city, to a new program, completely different environment than I was used to, that was scary. And was definitely an adjustment period. But I think after that initial adjustment period, it was exciting. I mean, challenging and also stressful at times throughout. Yeah. But I think it was the first year or two where it was really hard to get adjusted. And then after that, kind of the pros definitely outweighed the cons. And another thing that I hadn't kind of appreciated before starting grad school, but has ended up being actually a tremendously integral part of my graduate education was, and maybe this will sound a little cliched, but just the people I met, or my cohort in the graduate program there. So there was in my year in the physics department at MIT, there was quite a large incoming group of grad students. And within the astrophysics division that I was a part of, there was about a dozen of us. And I mean, I think there are some perhaps external stereotypes or perceptions of what the culture might be like in a physics grad program at MIT, of being kind of uber competitive and people only working on their research. I mean, people are very dedicated to the work that they do, but my experience was that cohort of friends became some of my closest friends to this day, and that everyone was really supportive. We kind of bonded over doing StatMech problem sets and had kind of a StatMech social mailing list that is still active to this day. And so now, some of my friends went off to do kind of other things, working for tech companies in Silicon Valley, but there's a number of us who are now kind of faculty members across the US and Canada, kind of at similar stages. And so having that kind of cohort and friend group, and I think, and I hope now lifetime group of friends, was also very special. And I know people go to business school to network and meet people. People don't necessarily go to physics PhD programs thinking, oh, a main reason I'm going is to meet people. But that for me was an unexpected outcome that has been very meaningful to me.
Yeah. Yeah. And it also seems like, thinking of the analogy of that in business school, it's also such a smaller group of people, even in the world, that are specializing in what you're specializing in, or even understand it, that, it would seem such a shame if that relatively small group of people all kind of, were in their silos, as opposed to, really being community for one another. And it sounds like that community really, really developed there. Was that sort of a culture that was nurtured? Were there professors or mentors that were helping to nurture that culture?
That's a good question. My experience at the time, there were certainly kind of professors who were kind of contributing positively to the culture there. I think the more important factor was, again, kind of the grad students who were a couple of years ahead had kind of somehow, through their grassroots effort, had kind of a strong culture, and that kind of felt a positive culture, and that kind of fed into kind of the more junior grad students that were coming up behind them. Mm-hmm. It's hard for me kind of now, several years later, to kind of analyze kind of how did that work? Was it just kind of a serendipitous thing among the group of us who happened to decide to go to MIT that particular year? Or what were the broader kind of structural things at play that helped that happen? And I don't know that I have a good sense of that.
But yeah, I actually think you've explained it quite well, because also it is going to be so many interlocking, ingredients, or, some of them difficult to know.
However it came together, it did. And yes. I definitely learned a lot, both personally and professionally, during my time at MIT.
Yeah. So how did you specifically get into the study of exoplanets itself? Like, how did that become your specialty?
Yeah, that's actually an interesting story, because I had no idea what I wanted to do in research. When I first arrived at MIT, I found many different topics interesting. And in my first year at MIT, I worked on 3 different small projects with 3 different professors. They were all related to astronomy and astrophysics, but very different topics. One was on cosmology, big structure of the universe. One was on exoplanets, and one was on gravitational lensing. And I actually exoplanets wasn't so big of a field when I first got started. And it just so happened that there was a regular weekly journal club that had just started up in the Astrophysics division, and I was one of the first students kind of assigned to read a paper, someone else's paper that had recently been published, and give a brief summary of it to the whole department. Mm-hmm. And the paper that I just happened to have selected was a paper about the modeling of the interior structure of super-Earth exoplanets. And it was just because it happened to have appeared on the archive preprint server the week before. I thought it sounded neat. And so I presented about it. And my eventual thesis advisor, she actually wasn't at that particular event, but somehow word had gotten back to her. And my thesis advisor, Sarah Seeger, had actually just arrived at MIT, having moved to MIT from the Carnegie Institution of Washington. And so she had just arrived, was, I guess, looking for grad students. And so I was kind of put in contact with her, and the rest is history.
Nice. Okay, so you've gone from, looking at the stars to knowing you love science, and now you've really got a focus. And so once you graduate from MIT, what happens next? How do you make those next decisions?
Yeah. So as someone kind of modeling and exploring the interior structure of small exoplanets, so planets that are Neptune size and smaller, my PhD actually was really well timed, because when I started out and with that first paper that I read for the journal club, there weren't yet any known planets smaller than Neptune any known exoplanets smaller than Neptune for which we had a measurement of both their mass and their radius. So of both their mass and also their size.
Mm-hmm.
And with a mass and a size, we can compute kind of the density, and that at least gives us some range of possibilities for what the planet might be made out of.
What's in there, yeah.
Yeah, what's in there. And part of what I was doing for my PhD was making kind of the more detailed models to try to answer that question, what's in there? And I was focusing on the small planets. And when I started making these models, essentially we didn't have any to apply the models to, where we had a constraint on both the mass and the radius.
Mm-hmm.
And during my PhD, the first one was detected, or the first transiting sub-Neptune-sized planet was detected. And then we got a handful. And then the Kepler Transit Survey was launched and was looking for transiting exoplanets from space. And so all of a sudden we start to get kind of statistical numbers of these planets with measured masses and radii. So it was a really exciting time. And I still didn't have a clear picture of like what I eventually wanted to do, but I knew I wanted to keep doing what I was doing right then, because there was all this exciting data coming in, and I was working on this hot topic in an exciting field. And so I applied for postdoctoral fellowships, essentially to continue work as a researcher after the completion of my PhD. And so that's what I did. I ended up going to CalTech as a Hubble Fellow to continue my work on modeling the interior structures of planets, trying to figure out what planets are made out of, now kind of using this wonderful statistical sample of data. And it was while I was at CalTech that I started mentoring undergrad students and helping to advise them on research projects. And I would say that's the point where I realized, oh, I really enjoy working with students. Mm-hmm. Mentoring these students in research is the most kind of meaningful and nourishing part of my day-to-day job than as a postdoc. And so that was the point where I realized, okay, I definitely want to have a career where working with students is a big part of my job description. And so the natural example of that would be being a professor at a university.
Yes. And so how does that realization while you're at CalTech, how does that eventually land you as a professor at UChicago?
Yeah, so essentially that realization led me to apply for faculty positions. And I certainly targeted faculty openings at kind of universities, as opposed to, say, trying to target being a research scientist at a national lab or at NASA or somewhere where I would focus just on research but have less of an interface with students. And so it was, in the midst of, after applying and kind of interviewing various places, I got a job offer from the University of Chicago and was delighted to accept and start as a faculty here. Yeah, I feel like my path has had kind of various serendipitous events. And I think the stars aligning for to get a job offer from the University of Chicago is one of those major kind of fortunate events that I know it's not 100% luck, but I know there's also various circumstantial factors that come into play. And I'm very grateful that that worked out.
And also what an apt metaphor for an astrophysicist.
Yeah.
But the stars aligned. Yeah. And so now that this path has taken you here, and with an ear towards the, who might be listening to this podcast, I'd love to sort of, think broadly about where you have come and sort of what you've learned on the way about this path. What has been the biggest, from the moment you realized you would like to be a professor to now that you are, what is the biggest surprise? Something you really would never have guessed would be part of that career or part of that path when you were at CalTech just starting to realize where you wanted to go?
Yeah, so I think one of the big surprises or things that maybe I knew on some level but hadn't fully appreciated, that I've kind of grown to appreciate since deciding I wanted to be a faculty member and today, was how important kind of being able to pick myself up from failures would be. And I'm sure that it's kind of a general kind of good life skill, but certainly kind of no matter what, when applying for faculty positions, everyone will be declined from various places. And same thing, kind of applying for grants, you end up getting a lot of no's and some come through.
Making friends with rejection.
Yeah, exactly. And learning how to be resilient and learn from the experience and still carry on. Because there's a lot of positive things. Like sometimes a grant comes through. Working with students I find very nourishing, but there's also kind of it's easy to kind of skim over the successes and kind of get kind of weighed down by all the rejections to grant proposals and
I think
everything.
There's literal science on that.
And so one thing that I think I didn't fully appreciate and have definitely grown to learn or kind of build up my thick skin or resiliency to, or just learned how to better process and keep my eye on the big picture, was kind of how to deal with the kind of continual kind of rejections. And and then the other kind of complementary thing that I learned, and maybe this is part of the answer to kind of the first surprise, was the importance of carving out a little bit of every day to focus on writing or to focus on working on kind of a project that's really important to me. Because there's so many demands on every professor's time, like from teaching, service, kind of projects where you're helping out other collaborators, which are fun too, but there's kind of more demands on our time than any mere mortal can fulfill. And so, and especially, for people who, like me, like I don't want to disappoint anyone else. I really want to help everyone else. I've had to learn to kind of carve out, even if it's just half an hour a day, for the project or the paper that's most meaningful to me, and kind of to give that to myself first, and then kind of I can get wrapped up in all the other demands from other people on my time.
Well, and I think that is such beautiful wisdom, especially for people who may be at an earlier stage of that path. Because I think in so many fields, we think when we're starting, well, I'll have to do everything that other people need me to do now. And, 10, 20 years from now, I'll do something that's my own. And that time, if you don't make it, never quite seems to arrive. Because as you said, there's already so many demands on your time than anybody could possibly fulfill. And so just like, keeping that finger on your own pulse it seems like, is really what probably keeps a lot of people from burnout or
Yeah.
just
And having the courage to say no sometimes as well.
Yes.
Yeah, that's something that I've had to learn as well along the way.
Yeah. So my final question. So, we started with you as, a kid in Nova Scotia looking up at a sky full of stars. And now you are a professor at the University of Chicago after so many stops in between. If you could time travel back and tell that child version of yourself a little bit about what your life is like now, what would you tell her?
Gosh, that's a really hard question. Maybe the thing I would say is that she can do it. That even if she doesn't quite know what her dreams are yet, when she figures them out, to kind of go for them and to not doubt herself, because she can do it.
Well, thank you, Professor Leslie Rogers, for your time today. And course takers, if you enjoyed listening to today's interview, please check out the other ones. Leave us a comment, subscribe, follow, and share this podcast episode with your friends and family. You can find out more about the University of Chicago through uchicago.edu or the university's campus in Hong Kong through uchicago.hk. Stay tuned for more, and thanks for listening.